Okay, this lesson is 13.4, compound probability. So when you think of the word compound, you might think something that happens over and over again, and that will explain what we're doing with this probability. Okay, identifying independent and dependent events. Is the outcome of the trial an independent event or a dependent event? So when you think independent and dependent, you guys have heard those words a lot. Independent would mean nothing affects it, it's on its own, and dependent would mean it is created or it depends on something else happening. So if you choose a number tile from 12 tiles and then you spin a spinner, does what tile you choose depend on what you spin? Those are two separate events. They don't relate to one another, so this would be independent. And then part B, pick one card from a set of 15. Then, without replacing the card, pick another card. So if I have cards 1 through 15, I'll write this out real quick. And then I choose one of these. I choose a card at random. Let's just say it's 6. So 6 is now gone. And then, without replacing the 6, I choose another card. The probability of what you're going to choose the second time definitely depends on the event that happened before it, because now I only have 14 cards to choose from instead of 15. So this would be a dependent event. It depends on what card you chose before. So finding the probability of independent events, here's an example. A desk drawer contains 5 red pens, 6 blue pens, 3 black pens, 24 silver paper clips, and 16 white paper clips. If you select a pen and a paper clip from the drawer without looking, what is the probability that you select a blue pen and a white paper clip? So two things are really happening here. I'm going to highlight those real quick. We are going to select a pen, and then we're going to select a paper clip. So those are two different events. One does not affect the other. It's not very specific in this example, but they are not together. They're both in separate drawers if you want to look at it that way. So the probability, let me change my, there we go. The probability that I select a blue pen, I have to first think about how many pens do I have. So I have 5 red pens, 6 blue pens, 3 black pens. So that would be 14 total pens. How many are blue? 6 are blue. So I have a 6 in 14 chance of selecting a blue pen. Now what's the probability that I pull a white paper clip from the drawer that has clips? Well, how many clips are there? We've got 24 silver paper clips and 16 white paper clips. So I have 40 paper clips. How many are white? We've got 16 white paper clips. Okay? If you want to reduce this, it's a good idea. It's always better to work with smaller fractions. So 6 and 14, I can cut them both in half, so 3/7. And then 16/40, they both are divisible by 4, and also 8, so that would be 2/5. How to find the probability of multiple independent events? What's the probability that they will occur? You take the first independent event and you multiply it to the second independent event. So the chance that I pull a blue pen is 3/7. The chance that I pull a white paper clip is 2/5. So I multiply those together and I'm going to get 6/35. So if we put that into our calculator, we're going to figure out the decimal and we can turn it into a percent. So 0.17, which means about a 17% chance that I'll pull a blue pen and then a white paper clip. Okay, moving on. Let me erase my ink. So we already did that, and here is the formula for finding the probability of independent events. You would take the event of A happening, or the event A happening, probability of event A happening, times the probability of event B happening. So I'd pause this video, write that into your notes. Okay, now finding the probability of independent events, practice. Let's say we roll a standard number cube and then we spin a spinner. Those are independent, they don't affect one another. What's the probability that you roll a number less than 3? Well, let's think of a standard number cube. I could roll a 1, I could roll a 2, a 3, a 4, a 5, or a 6. How many are less than 3? 1 and 2 are. So 2 out of 6, or 1/3, are less than 3. So the probability of rolling a number less than 3 is 1/3. Then it also asks you, what is the probability that the spinner lands on a vowel? So we've got U, W, V, and X. So the only vowel I see is U. So there's 1 out of 4. The probability that I land on a vowel is 1/4. So if I want to know what's the probability that I roll a number less than 3 and then land on a vowel, you're going to take 1/3 times 1/4, and you're going to get 1/12. So if you plug that into your calculator, you will calculate the percent. So this is approximately 0.08. So you have an 8% chance of rolling a number less than 3 and then spinning a vowel. Okay, mutually exclusive. Student athletes at a local high school may participate in only one sport each season. During the fall season, 28% of student athletes play basketball, 24% are on the swim team. What's the probability that a randomly selected student athlete plays basketball or, and this is the most important word in this problem, is on the swim team? So they're just asking you, if I choose a random student, what's the chance that they swim or they play basketball? Well, 28% play basketball, 24% swim. So what's the probability that they play basketball or swim? Would just be those two added together. So that would be a 52% chance that a student selected at random would be involved in one of those sports. Here is the formula for that. The probability of A or B happening is the probability of A plus the probability of B. So independent events, it's multiplication. Mutually exclusive events, it is addition. I'd pause this and write this into your notes. Okay, so one last example of that. In the spring season, we've got 15% of athletes play baseball, 23% are on the track team. What's the probability of an athlete either playing baseball or running track? So that would be 23% plus 15%. There's a 38% chance that a student selected at random would be involved in one of those sports. Okay, so next one, probability of overlapping events. What is the probability of rolling either an even number or a multiple of 3 when rolling a standard number cube? Now there is a formula for this, but it is easier if you write it out. Probability of rolling either an even number or a multiple of 3. So we've got a standard number cube. 1, 2, 3, 4, 5, 6. Those are my options when I roll. What's the probability of rolling either an even number? That's even. 4 is even. 6 is even. Or a multiple of 3. 3 is a multiple of 3. 6 is a multiple of 3. So out of all 6 possibilities, 4 of them fall into one of those two categories. They're either even or they're a multiple of 3. So you have a 2 and 3 chance, or approximately 67% chance of rolling a number cube and getting one of those categories. So here is the formula. You can write it down, but I would suggest that you just write out all of your options if it is a basic, simple example. So pause here, write that into your notes. So what's the probability of rolling either an odd number or a number less than 4? So if I write all these out again, instead of using the formula, I'm just going to do this because it's quicker. A number less than 4, 1, 2, 3 would be less than 4, or an odd number. 5 would be odd, 3 is odd, it's already underlined, 1 is odd, it's already underlined. So again, I have a 4 in 6 chance of it being in one of those two categories. So 2/3 or 67% chance.